All right, class, this is pre-algebra 11.1, and we're talking about square roots. So chapter 11, dealing with roots and such, and so we're going to start off with square roots. So 11.1, square roots. All right, some terminology. First off, we need to learn the aspects of a root. All right, first off, you've got the actual symbol there. Let me grab my blue here. So you've got the actual symbol, and a lot of people call it a square root symbol, and that's not technically correct. In reality, the symbol is the radical sign. It is the radical sign. So if you look back here to A, the radical sign. And the radical sign simply indicates the operation of a root, the operation of a root. Again, operations in mathematics are things like multiplication, addition, division, subtraction. You know, when you have a raised dot, the raised dot tells you to multiply the numbers. When you have a radical sign, the radical sign tells you to take the root. It's an operational sign. Okay? So the radical sign tells you to do an operation. And in this case, taking a root. And we'll talk about what that is in just a couple minutes. All right, so what do you call everything underneath the radical sign? In this case, we have just the letter A. But what is everything underneath the radical sign? That's called the radicand. The radicand, R-A-D-I-C-A-N-D, the radicand. The radicand. So you have a radical sign, you have a radicand, and the radicand is what you take the root of. It's what you take the root of. I know that's not the greatest English, but that's good math, right? What you take the root of. You take the root of the radicand of everything underneath the radical sign. Now, there's also one other aspect to radicals, and that's this: if there's a number in the little crevice. Now we're using a variable to represent any possible number. But the number that would go in the crevice is called the index. The index. All right, so let's come back down here to C and write in index. And what does the index do? It indicates what kind of root it is. The index indicates what kind of root it is. There are all different kind of roots. You can take a square root, a cube root, an eighth root, a 12th root. No root canal, thankfully, but you can take all kinds of different roots. And so the index tells you what kind of root it is. And so if you look at the asterisk here underneath C, it says if no index is shown, the index is 2. And it is a square root. So when there's nothing in the crevice, the index is 2. And that's something you're supposed to know and understand. Now, let me give you an analogy. You don't need to write this in your notes, but look right above the word square there. You know, if we had just a variable x, we understand that there's one x, right? But we don't write the 1 in front. But we know it's 1x, but we don't write that 1. We know it's there. Also, what would be the exponent of this x? Well, it's also a 1, but we don't bother to write the 1 because when there's nothing there, we know it's 1. Well, with our radical sign, when there's nothing in the index, there's nothing there, then we know that it is a square root. So when there's nothing shown in the index, then we know it is a square root. So for example, if we had the symbol there, and I don't know, we're going to let's stick the number 10 in for the radicand. We know that this index is a 2, but it's not shown. Okay? We don't need to write a 2 in there because we know when nothing is there, the index is a 2, and therefore we are doing a square root. All right, so let's talk about square roots then. What is a square root? So 2, what are square roots? Well, we already said the index is 2. And what does that do? See, the index tells you, again, what kind of root it is. So the index tells you what number times itself, and this matches the index. 2 times equals the radicand. A square root, what number times itself? 2 times. If we were doing a cube root, don't write this, but if the index were 3, it would be what number times itself 3 times. If the index were 4, what number times itself 4 times? If the index were 5, what number times itself 5 times, etc., equals the radicand. That's what roots are. So in this case, a square root, what number times itself 2 times equals our radicand. That's a square root. All right, so let's do a couple examples here. Square root of 9, pretty simplistic problem. So again, we look at this, the index is not shown, but we know it's a 2, because we know when there's no index shown, the value is 2. So we say to ourselves, hey, what number times itself 2 times equals 9, right? The radicand. What number times itself 2 times equals 9? And we know the answer is 3. Why is the answer 3? The answer is 3 because 3 times 3, that 3 times itself 2 times equals the radicand of 9. This is what square roots are. What number times itself 2 times equals the radicand. You know, you got the same thing here with the square root of 25. Okay, I know it's a square root. Therefore, I know what number times itself 2 times equals our radicand of 25, right? So we got a radicand of 25. And therefore, the answer is going to be, hey, what number times itself is a 25? Well, the answer is 5, right? And again, why would that be? Because we know that a 5 times 5 equals the radicand of 25. Okay? But the answer itself is 5. Square roots, what number times itself 2 times equals the radicand. All right, even roots actually have 2 answers. And I should say technically have 2 answers. And a lot of times we're going to disregard the negative part of the answer, but they technically have 2 answers, and I just want to go over that with you here. So, A, the positive answer is called the principal root. Principal root, and I somehow left the L off the word principal when I originally did this, but it's called the principal root. So, you know, again, we look at the example here and we're saying, all right, the index is 2, there's a square root. What number times itself 2 times equals 16? The answer 4, right? And hopefully you would agree with that. The answer is 4. Here, let me get rid of my shade so I can move this up. But here's the reality. Since a negative times a negative is a positive, the answer can also be negative. So if I go back up to A, not only can the answer be positive 4, but the square root of 16 also equals negative 4. And why? Isn't negative 4 times negative 4? Doesn't that equal the radicand of 16? And the answer is yes. So with B here, we've got square root of 36. So our solution is going to be, one of them is going to be 6, right? Because if you look right here, 6 times 6 gives us the radicand of 36. But negative 6 is also a solution because, again, negative 6 times negative 6 equals our radicand of 36. So technically, the answer is plus 6 and also negative 6. Technically, the answer. And it can be written together as one solution. You'll see this at times. We'll use the plus sign. We'll put the minus underneath and the 6. Now, this means the 2 solutions of plus 6 and also minus 6. That's what that means. When you see plus minus, it means the plus 6 and also the minus 6. Okay? All right, number 4. You can't take an even root. What do I mean by an even root? I mean an even index. Okay, so this would be an index of 2, excuse me, 4, 6, 8, etc., right? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, any kind of index where it's an even root. You cannot take an even root of a negative radicand. They don't exist within the real number system. So you don't get a real number answer. So look at our example here. Okay, so here we have an even root because we have a square root, right? Our index is 2. And we have a radicand of -4. And so the question is, what number times itself 2 times equals -4? Some students will usually say something like 2 times -2. Well, you can't do that. That's not a square root. That doesn't work because it's not the number times itself. The first one's a positive, the second one's negative. You can't do that. Your only possible choices are +2 times +2, and that doesn't equal -4. Or -2 times -2, and that doesn't equal -4. Nothing works. There are no real numbers that work. So what we say is no solution, or we can say not a real number. No solution or not a real number. Now what we'll find is when you get up into Algebra 2, we'll talk about imaginary numbers. You know, we're dealing so far with the real number system. You say imaginary numbers. Yeah, there are such things as imaginary numbers. We'll save that for a little bit later. That's coming down the road for you, all right? But for right now, when we have an even root, even index of a negative radicand, we'll say no solution or not a real number. All right, number 5. When the radicand is, and the word is should be in here. Sorry about that. When the radicand is not a perfect square, the solution is an irrational number. An irrational number. And we talked about irrational numbers before. And irrational numbers are numbers that cannot be written as a fraction. Numbers that cannot be written as a fraction. I'll review that again in a minute for you. So radicands that are not a perfect square. Well, let's first off talk about the perfect squares. Perfect squares are numbers like 1, which is a 1 times 1, a 4, 2 times 2, a 9, 3 times 3. What would be the next one? 16, right? For a 4 times 4. The next one would be 25 for a 5 times 5. And the next one, 36 for a 6 times 6. And 49 for a 7 times 7, etc. Whoops. Oh, it figures. Gets rid of them all, right? Let me use my eraser here, etc., right? ETC, not ECT. That's why I'm erasing that. So, etc. And by the way, we can take the square root of 4, right? We can take square root of 1 and get 1. We can take square root of 4 and get 2. We can take square root of 9 and get 3. We take the square root of 16 and get 4. Take the square root of 25 and get 5. Take the square root of 36 and get 6. Take the square root of 49 and get 7, etc., right? So, but when you're taking the square root of a number that's not a perfect square, you get an irrational number. So if you were to take 5 and punch your square root button, now you should on your calculator have a square root button. Sometimes it's a button above. It'll look something like this. If you look off to the right, it'll either be just the square root symbol, nothing else, or maybe it'll have an X as the radicand, and it'll be the square root of X, or maybe it'll have an N as the radicand square root of N, but you have that button somewhere. So in a lot of calculators, you punch in the 5 first and then that button. In some other calculators, you got to punch the button first and then the 5. So hit the square root of 5 and you get 2.236067978, etc. Keeps going on and on and on and on. Now, this should make sense, right? Because look at the radicand. What number times itself 2 times is a 5? Well, 2 times 2 is 4, so we're going to be a little bit bigger than 2. 3 times 3 is 9. We got to be less than 3. We're about 2.23. If you multiply this number times itself twice, you're going to get 5. But this is an irrational number. We can't represent it as a fraction. It's a non-terminating, goes on forever, non-repeating. It has no pattern to it. Non-terminating, non-repeating decimal. All right, so an irrational number, and that's what's going to happen when it's not a perfect square. Okay, it's not a perfect square. All right, look at D. The root will be the actual root is going to be between two positive integers. So this way we're getting an estimation. We're not getting an exact answer. We're just figuring out the two integers, counting numbers of which the root is between, the solution is between. All right, so the way to do this is you look at the radicand and you say, hey, what is the perfect square lower than 53? And the answer is, right, the square root of 49. Solution to that is 7, correct? What would be the one on the bigger end? Well, what's an 8 squared? 64, right, is the bigger one. And so this is between 7 and 8. So did you see what I did there? I looked for, I'm at a 54, I'm at a 53 here. And I'm thinking, what's the perfect square lower than 53? And it's a square root of 49. I can get a 7. And of course, then it would be the next number higher, would be an 8 is a 64. And so that is between 7 and 8. Okay? All right, next thought. Adding radicals. Adding radicals. What do you want to do here? You want to take the root and then add in a situation like this. Take the root and then add. So, pretty simplistic. What is the square root of 9? Answer 3. What's the square root of 1? So again, you're looking what number times itself 2 times equals a 1. The answer is 1 because 1 times 1 is 1. 3 and 1, 4. Final answer. Look at something like B. If you want to do it yourself, you can pause the video and go ahead and solve it and then start the video again. But square root of 81, hopefully you're thinking 9. 9 times 9 is 81. We still have this minus sign. Don't forget it. Again, be orderly in your work. Notice how I'm going below. The square root of 81 has become a 9. The negative's still there. The square root of 169, right, I'm going to use my red here, is a 13. 13 times 13 is 169. And now I have 9 positives and 13 negatives. Final answer, and hopefully you're thinking 4 negatives. Now in C, it's a little bit different situation. Notice that the addition is in the radicand. So it's underneath the radical sign. So in this situation, we want to do the addition first. So this is going to be the square root of 144 because the addition is all part of the radicand. Now I'm ready to take the square root. What number times itself 2 times is 144? The answer 12. And away we go. Okay? So that's the way you're going to do things. Now, let me mention this. Earlier I mentioned the principal root, and then also you can have a negative for any square roots. But notice we don't bother with the negatives. So back at A, I didn't say plus or minus 3, and I didn't say plus or minus 1. I didn't say plus or minus 9, etc., because it just makes things a little bit more complex. So for right now, we're just really basically worried about the principal root. Okay? So in any kind of problem, right now, you're just taking the principal root, and that's fine. All right, last thought here. Last thought. As always, with all mathematics, don't forget to follow the order of operations. And of course, you all remember the order of operations, right? Hopefully you're thinking of it right now. Got something in your brain? All right, are you thinking evaluate all exponents, then multiplication, division, left to right, addition and subtraction, left to right? Well, with that all exponents, really involves radicals. So you want to do radicals before you do any multiplication and division, before then you do any addition and subtraction. Okay, so we've got a radical here, all set and ready to go. Square root of 9 is 3. Of course, a number written in front of a radical is just like any number written in front of a parentheses. The operation will be multiplication. There's nothing in between. This is also multiplication. I'll use a little raised dot there now that I've got my 3 to distinguish 5 times 3 instead of 53, right? Okay, in the second part, I've got to simplify this radicand first, don't I? So really I end up with a negative 2 times the square root of 25. Now I'm able to perform the operation on the radicand, and the square root of 25 is 5. Still have a negative, whoops, give me my black, still have a negative 2, and that's times. And now I'm down to all multiplication or division, so 5 times 3 is 15. And a negative 2 times a 5 is a negative 10. And we can finish this off very simply as a 5. Okay? Order of operations. Let me show you one more. And this one involves some division. So remember, the fraction bar is also something that gives you order in the order of operations. So I want to come in here and take care of this radicand on the top. So I'm going to square root of 36. Right? Let's go ahead and take care of the radicand on the bottom. So on the bottom, I'm going to get the square root of 144. Again, notice what was to the left is what became the right. I'm working left to right because I'm dealing with a fraction. Okay, don't forget your negative sign. It's there out in front. It's got to stay out in front. What's the square root of 36? 6. So we end up with a negative 6 on the top. On the bottom, what's the square root of 144? What number times itself 2 times is 144? The answer is 12. So we end up with a negative 6 over 12. And when you reduce that, hopefully you say negative 1/2. All right, that's the lesson. Now, you 7th graders, I know you guys are away on a field trip on Monday, so you need to do the homework to this lesson. Everybody else will be doing it in class on Monday. So those of you on the field trip on Monday, page 453, you need to do numbers 1 through 3, 5, 7, 11, 12, 23 through 34, 38, 45, back to 44, that's on purpose, and then 48, right? And as always, make sure that you're writing the original, make sure you're showing work where you can show work, all right? Just follow what I did in the video as far as work goes, and that's what I'll want to see on your paper. All right, square roots. What number times itself 2 times equals the radicand? And let me finish with this thought. Don't forget to know your terms. The radical sign up here top right, radical sign, right? You need to know what the radical sign is. We need to know that everything under the radical sign is called the radicand, and we need to know that any number in the crevice is called the index, and if there is no number there, the value of the index is 2, and it's a square root. All right, that's the lesson.